Next case of permutations that we look at. So the third case. This time we got n objects. We're going to use them all, but they're not all different. So some of the objects are the same. Now, let's investigate this by narrowing it down, I guess, to the simplest case that we can. So if we've got two objects, and they're all different, obviously, there's only two ways I could arrange them, A and B, or B and A, and as we discovered yesterday, that's two factorial ways of doing it, or two. How will it change if they're both the same? Well, if they're both the same, obviously there's only one way I can do it now, A and A. So the question, I guess, is, how do I get from 2 to 1? Okay, well, let's see if we can pick up a pattern by now looking at three objects. Three objects, if they're all different, so I'll call them A, B, and C, then we have our 3 factorial or 6 ways of doing it. Now, if two of them are the same, okay, so now I'll just call them A and B. So I've got two A's and a B. 3 ways of doing it. So I went from 2 to 1 when there was 2. I've gone from 6 to 3 when I've got 3 objects and 2 of them are the same. So again, the question is, what's the pattern? How did I get from 2 to 1, did exactly the same thing, and got from 6 to 3? If all 3 are the same, then now there's only one way of doing it. So I've gone from 6 to 1. Let's have a look at 4 objects. Now, if they're all different, there's quite a few there now, A, B, C, and D, we've got 24. Okay, when we had 2 objects, we went from 2 to 1. When we had 3 objects, we went from 6 to 3. Logically, we would expect, if I'm going for 4 objects, I would go from 24 to, yeah, it looks like we're halving it. So let's have a look. We'll make 2 of them the same. There's all our possible outcomes, and sure enough, it's 12. Now, if 3 are the same, what are we expecting without cheating and looking at the sheet? So some are saying 4, some are saying 3. Let's have a look. 3 are the same, we end up with 4, which I guess is the location I can put that one odd object there. So how did I go? And of course, now if there's 4 objects, there's one way of doing it. The way we've gone is we've not divided by 2 in that first case. We actually divided by 2 factorial. The number of ways we could have arranged those objects if they were different instead of being the same. And so then when I had 4 objects and 2 of them were the same, so it halved. But when 3 were the same, I divided not by 3, but by 3 factorial, the number of ways I could have arranged the 3 objects. So we can now generalise that. If we've got n objects, x of which are the same, number of ways I could arrange them is n factorial divided by x factorial. The number of ways I could arrange the same objects if they were different. Okay? So number of ways of n objects, number of ways of arranging the like objects if they were different. Okay, here's a good word, connorton. Student I taught many years ago, but I thought the name was good. Look at all those doubling up letters and things. So how many different words using all the letters in connorton? Well, all up there's how many words? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 11 letters all up. Okay. But I divide it by 2 factorial, because you'll notice there's 2 O's there. But I'll also divide it by 3 factorial, because there's 3 N's there. Okay. So all up we end with, what do we get? There it is. Wow. Try and write them all out. 3,326,400 different ways we could do it. Here's an extension question from the HSC. They do have to spell everything out because it is maths, not English. So just in case we were unsure, the letters A, E, I, and O, and U are what we call vowels. All right, vowels, yeah. Okay. How many arrangements in the word algebraic are possible? First of all, well, so 9 letters in algebraic, but there are 2 A's in there. So 9 factorial divided by 2 factorial gives us that. The second condition was, all right, we're now going to arrange them, but the vowels have to occupy the second, the third, the fifth, and the eighth positions. So first thing to do, look after our conditions. So the vowels, there are 4 vowels, we'll arrange those, 4 factorial, but 2 of the vowels are the same. Got 2 A's, so divide by 2 factorial. Now we'll arrange the consonants, that's the other type of letter by the way, and there's 5 consonants, they're all different, so 5 factorial, giving us a grand total 1,440. Okay, so we'll just add 10F now, where some of them are the same.